Yeah, the a ratio like a half probably means that we have a friction problem. Maybe we don't, we can see. What did you say the rake angle was? Positive, yes. And estimating it at 40-ish. Okay, 40 or 45 degrees is quite the rake angle. We would typically be a lot lower than that, closer to neutral. But some of that is just because of cutting in a weird geometry here. What did you decide the shear angle was? 22.732. Yeah, all right, good. So there is proof right there that the rake angle, that the friction force and the shear force are not necessarily perpendicular, because in this case they definitely would not be. So is there evidence of elastic spring back? No? Yes? I see some yeses and some nos. Where is there evidence of elastic spring back from the yes people? Yeah?
Underneath the tool.
Underneath the tool. So it is a little hard to tell because the angle could be a little bit wonky, but this cutting point is lower and it looks like the material has swung back here, which is why we have to have that relief angle on the back of the tool. We have to have some back clearance or relief angle so that the flank will not get rubbed. If you have stuff rubbing the flank of the tool, it will fail really quickly. It just creates heat and it doesn't do anything good for you. So we don't want that to happen because we care. Built up edge. Bummer. I heard you call it view. I think it's hard to know whether it's view or bouet. Bouet? It might be French. It's very hard to know. Anyway, so what has it done to the effective rake angle? It
Increased. More positive.
It positive did or negative did?
Positive.
That was distracting. Okay. Did it positive it?
That's,
think so?
That's what we interpreted based off of the
Okay. It's really hard to tell because we already have a rounded tip because we're so zoomed in here. It's a little hard to tell what it does. In general, the rake angle will cause it, the built up edge will cause it to be cutting down here. So that is a highly negative rake angle that you're cutting with there for the edge. And so it just kind of plows through the material. It is not a good thing. We paid a lot of money for them to spend a lot of time to hone that edge on the material and make it really sharp. And now we're cutting with goo. Yes?
Could you draw how it's a negative?
Well, it depends on where you think it's cutting it, right?
Okay.
So if it is separating the material right here, then let's see, that is positive. If it's separating the material down here, that's highly negative because it is leaned way forward and it is shoving that through. So it's a little hard to tell. But in general, what it will do after a while is create a highly negative rake angle, and it just sort of mushes through the material, creates a bunch more heat because you don't want to have a negative rake angle in this case, creates more heat and makes itself worse. So anyway, what did it do to the depth of cut? Yeah, kind of increased the depth of cut, so we lost some accuracy there. What did it do to the shear angle? It's hard to tell, isn't it? Yeah, who knows? Did something this shear angle, pretty hard to tell. Surface finish,
get uneven.
Yeah, it starts to get uneven. You get these things on top, so these chips get welded onto the surface, and it's amazing how rough those things are when you get a material welded back onto the surface. It really is not your happy surface. So, all right, great. All right, we're gonna look at chips. Skip this for just a minute. Here, one of these screens. We're gonna skip that. And we're gonna skip that. We're gonna do this. So chips. When we are creating chips, there are 4 main types of chips that you can get. The first is continuous, which is a lie. It just looks continuous. It isn't actually continuous. What is happening here is you have individual shear events like you would have normally, but they are happening so often that the chip just looks like it didn't really have shear events. And so, I think one of these, I don't know. This one is pretty good with that. So this is a continuous chip from turning. This is not what you want to happen in turning, because a chip this long just creates problems, right? It gets wrapped around everything. If this thing starts whipping around and comes at you, it is scary as heck. So that's one of the things that happens when you're using a manual lathe, is you get a big ball of chips and the chips get longer and they're whipping around, and then it will pick up the ball of chips and chuck it at you while you're standing. It's terrifying. If you're lucky, it'll throw it over your shoulder and hit the person operating the lathe behind you, but that doesn't always occur. Anyway, continuous chips, it is a good thing for the process. It means that you're putting in a reasonable amount of heat, and it's good. If you're making continuous chips, though, you need to have a good chip breaker, or you end up with a 10-foot long chip. This one actually used to be 16 feet long, but I broke it getting it out from behind the lathe.
Oh.
So that was my bad.
Were you trying to make it?
Sorry?
Were you trying to make a long one?
No, we were doing some weird cutting inside a part, and we didn't have time to deal with the chip being incorrect. We just needed to make the part and be done with it. We can have built-up edge. Built-up edge is terrible. If you're doing built-up edge, you need to change the processes. You need to do better, because that is not going to give you an accurate edge. It's going to ruin the surface finish of the part that you're making. It means you're putting way too much heat into it, and you need to use a different tool. Now, if we're on a lathe and we're running old school tools, to change the rake angle, we can just tilt the tool and change the rake angle. But in many instances, the rake angle is not adjustable. So in this end mill, the rake angle is right down here at the very tip, and I can't change that. You know, that's just the way that it was ground. And so if I want to change the rake angle, I have to go buy a different tool or get a different tool out of the tool room to be able to change that. Segmented or serrated chips, what happens here is that it's like the continuous chip, except that it is building up a bunch of stress, and it loads up with stress for quite a while. And then once it gets to a certain amount of stress, a huge shear event will happen. It will heat right along that edge, and that shear event happens, and then it will spend a while building up stress again. So in this case, you are definitely not putting too much heat into the process, because it's not happening all the time. This is happening almost as a brittle failure. And in fact, if you go to a discontinuous chip, it is happening as a brittle failure. And so you're building up a bunch of stress, and then bang, that happens in one quick shear event. One of the advantages of doing either discontinuous or segmented serrated chips are that you are not creating a lot of heat all the time, and the heat all happens in this little band and is focused in the chip. So there's a set of machining that we do that's called high-speed machining. We'll talk a little bit more about it next time, but what happens in machining is, in general, the faster cutting speed I have, which ends up being the higher RPM I use, my tool life will go down exponentially. So I turn it faster, tool life goes down. You know, if I make it twice as fast, tool life goes down to the 4th power. That's a bummer. And so what I end up needing to do is to slow it down. But if I slow it down, I make less money. But then physics helps us out at some point. If I turn it so fast, I can actually turn it fast enough that these shear events happen, all of the heat stays right here, and as long as I have a good tool that has a good coating on it, the heat won't actually get transmitted into the tool, and I can throw the chip away before it has time to transmit the heat through. And so all of a sudden, I can now turn the tool at these super speeds and get all the heat to go away, and I get my tool life back. So that's pretty cool. But it is very high speeds. So the speed for that to happen is like 16,000 RPM is the lowest speed for aluminum, and for steel it's 10,000. So of the machines that we have one machine that has a 15,000 RPM spindle, all the rest now have 10,000 RPM. So we can't do high-speed machining on any except for one, unless we use really large diameter cutters, which are super scary at that kind of speed. So anyway, we don't do that very much. All right, questions? Yes?
What's the difference between segments and discontinuous?
So the difference is this, it is hard to tell. I will give you that. The difference is this. The fact that they are not fully welded together as one chip. So it gets places where this shear event is so violent that the chip isn't even connected all the way through anymore. So it just is a level of violence beyond. Sad. You don't like to have that kind of event happen in our chip forming lives. Okay. Here we go. Now, everybody raise your right hand. Say, I promise I will not take the chips out of the little container.
I will not take the chips out of the little container.
Excellent. Good job. All right. So you're going to look at the chips, and you're going to look at them in the little container. It is very enticing to take them out. What happens then is they get spread all over. The custodians get mad because it looks like my office with a bunch of chips ground into the carpet, and then I have to make more chips, and that makes me sad. So what I want you to do is to look at the chips, and I want you to look at both sides of the chip. I want you to try to decide which of those 4 it might be, and then I want you to try to surmise maybe what might have been happening in the process of making that chip. And then after you've looked at one, you can swap with somebody else. They are labeled on the top of the little things as to what, well, they have a letter on top. We'll leave it at that. Oh, do we need another? One chip?
Find out where I can see both sides of it.
I think it's
I find it shiny. Finish off.
Yeah.
I don't know if it's supposed to be.
like the longer ones are usually really.
I would say segments.